Mourad Sultan Ezouidi. I'll just do it again. Start recording. So learners, how you are doing? It's Mourad Sultan Ezouidi, the mathematics teacher. Today we are going to see how can we solve polynomial to the power 4, of course using the new method in mathematics. That's called the discriminant formula of Mr. Mourad Sultan Ezouidi. I will go to show you, let's say, my books. Where this one? Yes, this is the book of Mr. Mourad Sultan Ezouidi. It had been published before, and I got my own SBN. So the title of this book is called Solving Polynomial to the Power 4. Is written and prepared by the researcher, Tunisian teacher Mourad Sultan Ezouidi. And in fact, I spent more than 14 years doing research, and finally I got new methods, new theories involving solving polynomial to the power 4, 6, 7, 8, 18, 12, and so on. So just to show you something here. This after. So let's now start, learners. If it is let's say, if we are going to solve polynomial to the power 4, you should use the discriminant formula of Mourad Sultan Ezouidi. This is another formula that really gives you the after calculation using the P minus 1 over the Q and S P minus 1 over the Q. Of course, you will get this value. This one I'm going to prepare another book talking or explaining this formula, but now we're going to focus on this formula, which is very important. And Mr. Mourad Sultan Ezouidi explained early how polynomials work with their own roots or their own zero, and the raised to power q, 3q, and so on. So here, learners, you can see this polynomial is equal to x raised to the power 4 minus 20x exponent 3 plus 2097 x squared minus 19,970x plus 49,300 equals 0. We can see that this polynomial is of form 4pq, where 4 designate its degree and q designate its order and not its order of multiplicity. Therefore, to determine the zero of this polynomial, learners, you just need to look for S or pq dash, relating to the formula LRPQ, where R goes through the set of numbers minus 1, 0, 1, 2, and 3. In other words, learners, we can let's say fix k equals 0, or suppose that k equals 0, we get let's say the value of s minus 1 over the I equal 1. For addition formula, l minus 1 is 1, and 0 is 20, L1 of all the q is 2097, from the coefficient of that is written, let's say, in front of the x terms, powers, of course, and L2 is 19,973 is 49,300. Now we are going, learners, to focus on this method, which is very important. It helps early learners to figure out the S N PQ dash, relating to the L N PQ. So here in this example, you are going to use this formula, which is called the discriminant formula of Mr. Mourad Sultan Ezouidi HSM. We continue proceeding. For S0 when k equals 1, we'll get S of 0. Just replace k with 1. It will be 0 from 0 to 1. Then n minus r, choose 1 minus r, and raised to the power r, multiply by minus l 0 of order q, all raised to the power 1 minus r l r minus 1 of order q. After calculation, learners will get s minus 1 equal 1, then s0 equal 0. Okay, this is the proof. Okay, that is already equal 0. Then we make s0r is minus 4 multiplied by 20, because minus n choose 1 is n is 4. Okay, 4 choose 1 is 4, multiplied by 0 is 20, we told before is 20, multiplied by 1, why 1? Because n minus 1 is 1, plus learners n is 4, multiplied by the 0q, which is here 20, we get 0. Okay, for the next for k equal 2, you are going to learn to find the value of s1 of order r. R can vary, okay, from minus 1 to n. Okay, by here this example we just fix r as it is as a constant. Okay, for additional information, okay, and for additional researches, r can be also raised to the power 1, 2, 3, and so on for other reason. For Mr. Mourad Sultan Ezouidi. Therefore, k r equals 0, k is 2. Okay, you please. Okay, 2. Okay, n minus r. 2 choose 2 minus r, and raised to the power r multiplied by minus l0 raised to the power 2 minus r multiplied by l r minus 1 over the q. Okay, after calculation, okay, and this is the proof of the method. Okay, we just substitute now, learners, we get s1 equal what, learners? The formula is minus n choose 2 l0 of order q raised to the power 2 plus n squared. This, okay, multiplied by l1 of order q. This, learners, is known by the discriminant, okay, of a quadratic formula, but the discriminant of quadratic formula is b squared minus 4ac. By this example of Mr. Mourad Sultan, the s1 is the negative value of the discriminant of quadratic equation. So this is a new formula, in fact, okay, because we use the formula of Mr. Mourad Sultan, which is this, okay, and this gives you all the values of s k minus 1 r. Okay, so therefore, learners, after calculation, we get the s1 equal 31,152. To find, let's say, s2, we should, let's say, suppose that k equals 0, okay, and distribute the discriminant formula of Mr. Mourad Sultan Ezouidi. Okay, after calculation, okay, this one is too long. Okay, okay, it's too long, but learners has to be familiar with this new formula of your own teacher, Mourad Sultan Ezouidi, and I wish through this books, okay, these methods and these theories can, let's say, can be spread out as quick as we wish. Okay, and this one is going to be for you learners. Okay, in fact, I'm tending to explain so many things in YouTube channel, okay, involving my own work, okay, may can help professors, teachers, and learners, students, and everyone that is looking for finding roots and thinking of this kind of polynomials, because in fact it's let's say it's very important, okay, to understand, okay, polynomials. Okay, so we thought that after 14 years of work we get this methods, and we explained this before. Okay, so after calculation, we found the S2, in fact we found it 0. To find the S3, just put k equal 4. A calculation, use the distinct formula of Mourad Sultan Ezouidi. You will get, of course, that is 0. Why? Because this is, we calculate S3 is negative 3 choose 1, multiplied by, of course, this is n here, 4. choose a 4, which is 1, multiplied by a 0, which is 20 to the raised to the power 4, plus 2, choose 2, because n is 4, 4 minus 2 is 2, so no need to write it. Just write this one, n is 4, 4 squared, multiplied by 20 squared, multiplied by L1, which is 2097, minus learners, minus what? Minus say n minus 3, which is 1, choose 1, no need to write it, n to the power, n 4 to the power 4, multiplied by 20, multiplied by 19,970, plus last one, which is 4 raised to the power 4, multiplied by 49,300. You will get a value of 0, okay. So here, as a conclusion, okay, we told that in fact that is 0, so we can say that all the formulas 0 of all the R2 or the R3 or the R are equal to 0, except those let's say S minus 1 PQ dash and S which is 1, and S1 PQ dash, which is we found before, that is 31,152. Therefore, to write this one, learners, just comes back, okay, comes back, Mr. Mourad, go down, okay, go down, yeah, good man, okay. Here, learners, we can say that this is our new polynomial to the power 4 is written as x to the power 4 minus s0r x3 plus s1r x squared minus s2r x plus s3. We told before that s0, 2, 3 are 0. We calculated before using the discrete formula of Mr. Mourad Sultan Ezouidi. Therefore, the new discrete formula of Mr. Mourad Sultan Ezouidi when k equal 2, so it will be s1r dash equal minus s1r ik plus 4 times s3r ok. We calculated s3 is 0, so it will be minus 31,152 squared plus 4 times 0, which is a negative number, okay. After that, we are going to give a negative sign to this value to be minus s1r dash equal 31,152 squared. Now, you know that this polynomial has 4 roots, okay, 4, 0, okay. You should find them out, okay. So, therefore, we suppose that, okay, go like that, Mr. Mourad. What happened? Okay. Okay, yes, good man. Therefore, x squared is learns minus s1, which is minus s1r plus the root of, this is r dash only, not double dash, okay, okay, no problem, okay, all over 2. So s1, please. So S1 is, we told that is positive number 31,152. Give a negative sign for that, will be negative 31152 plus the root of this one, the value of the discrete of Mr. Mourad Sultan Ezouidi, all over 2. So we can note that it is 0, so therefore the roots k belongs to 0, 1. We have 2 roots because x raised to the power 2, it will be L0 cube plus the roots of this polynomial, like we suppose that is x0 and x1 and k over 4, because you have raised to the power 4. Therefore, alpha and x, k belongs to 0, 1 is 20 plus 0, okay, why? Because this is 0 over 4, which is 5, so effectively 5 is a double root. Then finally we can go to change the sign here, okay. So minus s1r minus roots of minus s1r dash or dash, which is here equal a negative number because minus here and minus. So okay, just make the sum and put the negative sign for the output. It will be 31,520. Okay, 520. Okay. So it will be 31,152. Okay, this one 52 comes here, 31,152. Okay, this is okay. So we'll just this is not include this one. So therefore x and x k belongs to 0. 1 is the root of this one, okay, root of negative 31,152 exponential raised to the power ak pi, okay. Therefore we can see this minus 1, I will write as exponential I pi, okay. Then after calculation, okay, you can say that roots of this polynomial x0123 is the root of 31,152 exponential to the power 2k plus 1 multiplied by ip over 2. Therefore, the roots ik alpha and xk 0 and 1 is L0k plus xk and xz0 and 1 all over the 4. It will be 20 plus this value over 4. So these are the roots of this polynomial to the power 4 solved and written by Mr. Mourad Sultan Ezouidi. I wish that is an example for you learners to understand how can we work with polynomials. And this book now is in Amazon. You can say buy it, you can do whatsoever you want, okay, just to meet your needs, okay. I'm in fact publishing these books because I've looking of searching out the needs of my learners, the needs of the science itself, the needs of research itself, and to let these books speed out as soon as possible, okay. So therefore so many examples in fact, okay, you can work with, okay. This of course different example, okay, not the same example, okay, helps learners, students, teachers, professors to work with the new formula, the new discriminant formula of Mr. Mourad Sultan Ezouidi, okay. Therefore learners, we have also so many, okay, additional, go to addition, okay. I will show you my own books, okay. Okay, this one, okay. Okay. I wish that it works. Okay, I'll come here. Thanks for this this company, okay. In fact, I did so many things for me. All of these are my projects, okay. So here, for example, I got this new book, okay, methods de résolution du polynomial de Y4, means methods for solving or finding out the zero of polynomial to the power 4, okay, and also new theorems and methods of solving polynomial to the power n, okay. I will just download this and I will show you this one. So many books in fact, okay. Also learns we got solving polynomial to the power 18, okay. I'll come back. Solving polynomial to the power 18, okay. Whatsoever the polynomial we can let's say solve, okay. Okay. Open this one. Yeah, Ayub. Okay. So we told that this one is to the power, yes, methods. I will just, yes, methods. This one we did it. Okay, show this you. Okay, this one. This book already we did it. I will see from here it's better. Okay, this is polynomial to the power 18. Okay, we really solved polynomial to the power 18. I wish these books will we can reach these books and you can use, okay. And this is my copyright learners, okay. This is my copyright, okay. Okay, just a moment. Copyright, okay. Copyright, okay. This is copyright Mr. Mourad Sultan Ezouidi, HSM, copyright at 2021 Blue Books in Ocean team member of Omniscript Mass and Publishing Group. Okay, this is for the author only. Okay, so you can write, you can whatsoever if you are looking for, if you are interested, of course. Okay, let's see the point of the power 18. This is also learned, very important. This one is my theories, my methods. Okay, my methods for solving point to the power n. Okay, whatsoever, let's say, whatsoever, let's say the power, we already reached and discovered the new theorems to solve polynomial to the power n. Okay, haven't I asked some questions about GPT by fact he did answer me by solve polynomial to the power n is impossible, but alhamdulillah, thanks to God we got and also each theorem with its proof. Okay, each theorem with its own proof. Okay, theorem 2930 and its own proof. Okay, so that's it. Just telling you. Okay, keep going, keep loving mathematics. I'm here to help you. Okay, thank you and goodbye. I'll just close this one. Okay, I will stop.